Myself, Dr. Srikantha, Associate Professor in Department of Mathematics, Laxman Reddy Institute of Technology and Management, Hyderabad. Today I am going to discuss about differential equation. Course code is 252002, ordinary differential equations and vector calculus. So course objectives. The student will learn after completion of this course methods of solving the differential equations of first order and first degree, concept of higher order linear differential equations, concept properties of Laplace transform, solving ordinary differential equations by using Laplace transform techniques, the physical quantities involved in engineering field related to vector valued functions, the basic properties of vector valued functions and their properties, their applications to line, surface and volume integrals. So this is about course objectives. So after completion of this course, so what are the course outcomes means? From CO1, utilize the methods of differential equations for solving Newton's law of cooling and law of natural growth and decay. CO2, understand the solutions of linear differential equations with constant coefficients. CO3, explain the concepts of Laplace transforms and its significance in solving differential equations and evaluating integrals. From CO4, interpret the vector differential operators and their relationships for solving engineering problems. CO5, apply the integral transformations to line, surface and volume of different geometrical models. So these are the course outcomes of ordinary differential equations and vector calculus. So today I am going to discuss about unit 1, that is differential equations. So first we need to know what is differential equation. An equation involving dependent variable, independent variable and its differential coefficients is nothing but differential equation. For example, dy by dx plus y equal to 0. So here y is dependent variable whereas x is independent variable. So dy by dx plus y equal to 0. Here y is dependent variable whereas x is independent variable. So one more example from differential equation. So dou u by dou x plus dou u by dou y equal to 0. So here u is dependent variable whereas x and y are independent variables. So this is about just definition of differential equation. Now we can go for very important parameters to know what are differential equations. So first one is order. What is order of differential equation? Order is nothing but an equation involving highest order derivative. So for example, dy by dx plus y equal to 0. Here highest order derivative. Anyway, dy by dx plus y equal to 0. Here highest order only 1. So we can say that order is 1. Order is 1. Next parameter is degree of differential equation. Degree of differential equation is nothing but power of the highest order derivative. What is the power of this highest order derivative? So degree also 1. So there are two important parameters to know order and degree of differential equation. Order is nothing but highest order derivative present in given differential equation, whereas power of the highest order derivative is nothing but degree of differential equation. So we can go for one more example, that is dy by dx plus 2y equal to 0. So here equation is dy by dx, its power 7 plus 2y equal to 0. So here order is highest order derivative. So highest order means here only 1 present in this equation, whereas degree is 7. So these are the just basics of differential equation. So based on independent variable, we can classify differential equations into two types. That is, first one is ordinary differential equation. An equation is said to be ordinary differential equation, it involving only one independent variable. Example, d square y dx square plus dy by dx plus y equal to 0. So here y is dependent variable, we know already. X is independent variable. So here only one independent variable present, so that's why we can call it as ordinary differential equation. Next we can go for one more classification of differential equation, that is partial differential equation. What is partial differential equation? So based on independent variable, we can define what is partial differential equation. Here in this differential equation, two or more independent variable occurs in this type of differential equation. For example, here one example, dou square u by dou x square plus dou square plus dou square u by dou y square equal to 0. Example here, so u is dependent variable, whereas x and y are independent variable. So this type of equation we can call it as Laplace equation. This type of equation is nothing but Laplace equation. One more example from this partial differential equation, that is dou u by dou x dou u by dou y dou u by dou z equal to 0. So here u is dependent variable, whereas x, y, z are independent variable. So based on independent variable, we can classify this partial differential equation. So notation for partial differential equation is dou by dou x. So partial differential equation example. Now we can go for what is solution of given differential equation. Here there are two types, one is general solution and one more is particular solution. So how to identify whether given solution is general or particular means, so in general solution, number of arbitrary constant is equal to what is the order of given differential equation. So here one example, y equal to a e power x plus b e power minus x. Y equal to ae power x plus be power minus x. Here a and b are independent, a and b are constants. So this is nothing but general solution. Whereas one more solution is nothing but particular solution. How to get particular solution means just substituting some values to or particular values to arbitrary constant. Suppose y equal to a power ae power x plus be power minus x. This is general solution because it containing arbitrary constants. So how to get particular solution means substitute some particular values to arbitrary constant. Suppose put a equal to 1, b equal to 2. So y equal to e power x e 2 e power minus x. This is nothing but particular solution. So these are the just basics of differential equation. Next we can go for how to form differential equation. Form the differential equation by eliminating arbitrary constant. Y equal to ae power x plus be power minus x. So as we discussed already, so this is general solution because it containing arbitrary constant. So in general solution, how many arbitrary constant means there are 2 here. So what is the order of differential equation may get? So here order is 2 because of this definition, that is general solution. So number of arbitrary constant is nothing but order of differential equation. So first differentiate with respect to x. Y equal to ae power x plus be power minus x. So dy by dx is equal to, we know that derivative of e power x is e power x only. So a e power x. So derivative of e power minus x is nothing but minus e power minus x. So minus b e power minus x. So first call it given question equation number 1. This is equation number 2. Now here our aim is to eliminate arbitrary constant. So once again you can differentiate with respect to x, that is d square y by dx square, that is derivative of e power x is e power x, derivative of e power minus x is minus e power minus x. So a e power x, so minus into minus plus, by observing equation number 1, RHS part is nothing but given question only, that is equal to y. So I'll write this one from equation number 1, that is d square y by dx square is equal to y. This implies, so we can write short form also, y double dash minus y equal to 0. So this is the method we need to follow when form the differential equation by eliminating arbitrary constants they given. So by observing solution of this problem, so y double dash minus y equal to 0. So here order is 2. As we discussed already, general solution is nothing but arbitrary constant is equal to order of differential equation. So here order is 2 and also a and b are arbitrary constant. So it satisfies that condition. Now we can go for one more problem based on this topic. Form the differential equations by eliminating arbitrary constants, that is y equal to a cos x plus b sin x. So first called equation number 1. Then differentiate with respect to x. So dy by dx is equal to derivative of cos x is minus sin x. So minus a sin x plus derivative of sin x is cos x. So b cos x. So here our aim is to eliminate arbitrary constants. So that's why I am going to differentiate once again. So called equation number 2. Differentiate once again with respect to x. D square y by dx square equal to, so derivative of sin x is cos x minus a cos x, derivative of cos x is minus sin x, minus a cos x minus b sin x. So take minus outside, so minus a cos x plus b sin x. So by observing RHS of equation number 3, this is equivalent to given question only, that is equation number 1. So y is nothing but a cos x plus b sin x. So y double dash equal to minus, so this is nothing but y, this is from equation number 1. So this implies, so y double dash plus y equal to 0 equal to 0. So this is the method we need to follow when given question is formation of differential equation by eliminating arbitrary constant. Thank you.